This is the chapter review for Earth Science 7th grade. It will be covering geologic time, Earth systems, and mapping. Though this review will cover all of the items that will be on the test, it will not necessarily give you all of the answers and all of the information for each of the items. So make sure that you are also going through your notes. All right, first thing up today for discussion is the theory by Hutton called Uniformitarianism. No, I will not ask you how to spell that, but this is how you do that. Uniformitarianism. This is the idea that Earth is always changing. But it's also the same idea that the forces at work way back in the past are still the same ones happening today, and they're still the ones happening into the future. This theory is also the basis of modern geology. And next up is a geologic time scale. Now this is where things are going to get tricky, because this is where our history is divided into parts that are quite different. You need to know these parts, so make sure to give yourself lots of room to write this on your note card. There are 4 different divisions of time. So the very first one is an eon, and then underneath that would be the era, then the period, and then the epoch. All right, so we have Precambrian time. Okay, and within this are the eons of Hadean, Archean, and Proterozoic. Now, all of these together make up about 90% of Earth's history. Now, the fossil record during the Precambrian time is pretty small. You might even want to say it's microscopic, because all of the organisms during that time could not be seen without a microscope. Precambrian time started what we assume was about 4,800 million years ago, so that would be 4.8 billion years ago, and it ended about 543 million years ago. So about the first 4 billion years of Earth's history all happened within the Precambrian time. One thing you'll notice about the Precambrian time, so this time frame, is that it is not separated out into the other sections, such as the eras or periods or epochs. It is all just together. It's not separated out for one main reason. There just wasn't much happening back then. Remember, we didn't have a whole lot of change occurring in the biology structure and so forth of things on Earth. And so therefore, because there wasn't much going on, it's not really likely to be able to change it out or break it out into smaller periods like we can with all of this stuff up in here. Now, because there was so much going on up in this region, in the Phanerozoic era, or eon, then that's why it's separated out into all of these different things. And what you'll notice is we humans happened way up in this area, up where the mammals come into the picture. And in fact, it's right up in this tiny little section up here in the top, up in the Quaternary period, that we actually happened about 100,000 years ago. All right, that's the end of geologic time, and now we're going to talk about Earth systems. The systems. remember, number one, that we are a cycle. Everything here on Earth happens in a cycle. It has to go in a set, specific order. It cannot change. Regarding the Earth's systems, you need to know that there are 4 parts to the Earth system. The very first one being the biosphere. The next one is the hydrosphere. The next one is the atmosphere. And the final one is the geosphere. Remember, our book calls this the lithosphere, but we're going to actually call it the geosphere. Now, I use these colors for specific reasons. As we know, the biosphere is all living things. The hydrosphere is all water and everything that belongs in the water cycle. The the atmosphere is all of the air and gases that surround our world. And then the geosphere is all of our earthly type items, such as rocks, magma, lava, dirt. All of those sorts of things belong in that sphere. Also remember that all of these things affect the geosphere. So our atmosphere, such as wind, can affect the geosphere by wearing away the rock and moving it. The hydrosphere, again, water, actually can take parts of it, like that sand that we saw out at the Valley of Fire. Biosphere can even affect the geosphere because the plants actually grab onto the soil and keep it in place. And if that's not in place, then you're going to actually lose parts of the geosphere and it's going to move away. Last part I want you to remember about the Earth system is the difference between a closed and an open system. Both of them have matter and energy. But remember that in a closed system, matter cannot enter or leave the system. In an open, it can. Energy can enter or leave in either system, though. You need to be able to tell that within these systems, these things work together. Remember, a system is a system. It has to be in a specific cycle. It has to have all of its parts. If one of the parts is not there, then it's not going to be able to work. For instance, take a terrarium, right? Inside a terrarium, you have a set amount of water, a set amount of earth, a set amount of biology. And if one of those pieces was missing, then they're not going to be able to work as a system, and the system will actually die. Remember how each of the parts of that system work together. So obviously the plants let off oxygen. The system uses that oxygen to feed the other parts. The nutrients from in the soil feed the plants. And it all works together. All right, our last section is regarding maps and globes. First one is maps. And in this, I just want to skip straight to the different things that you'll see on a map, such as the scale, which the scale is the comparison of distance on a map with the actual distance on what the map represents. The next item is the legend. And the legend is the chart that explains the meaning of each symbol used on the map. Sometimes this is also called the key. And the last item is the compass rose, which is just going to tell you what direction is north, south, east, or west. For instance, if you take a look at this map here, you'll notice the scale is located here. The legend is down here, and the compass rose is up in this corner. All right, let's take a look at this picture here. First thing I want you to note are a couple of key sections, such as up here where the equator divides the Earth into the northern and southern hemispheres, or this one here where the prime meridian divides it into the western and eastern hemispheres. Remember latitude. Remember our little trick for remembering which one's latitude and which one's longitude. And remember that latitude are always going to have the labels of either north or south, whereas longitude is always going to have those labels of west or east. For instance, if I were to tell you to find a location of a city at, let's say 26 north by 15 east, what that's going to tell us is at 26 north, so we're going to go above the equator to 26 north, and then we're going to go to the east side of the prime meridian to 15 east, and we're going to find the location of that city somewhere in this sort of area, which would put us into the northern hemisphere and the eastern hemisphere. In this image, you'll see a picture of the United States, and this is actually a Mercator map, and because you can tell that the grid lines are all the same size. And you'll notice again up here at Greenland, it's much bigger than it actually should be. Here it looks almost the same size as the United States, and it's much, much smaller than that. But what you'll notice is that the equator runs along this line, and all of these numbers here are the latitude lines that run to the north or northern hemisphere, and all of these are in the southern hemisphere. Now if I look here, this is asking me to go to 16 north by 81 west. So if I go up to 16 north, which would be somewhere in this line, and 81 west, which will be somewhere right about here. So my location for 16 north, 81 west is roughly in this location. Again, this is telling of what hemispheres we're in because we are in the northern hemisphere and the western hemisphere. And finally, we're on to map projections. These are the different types of maps we will see and how they're distorted. Remember, map makers use different types of projections, but they're all going to have a distortion. They're going to misrepresent the Earth's surface in a different way. And there are 3 different types. Okay, the very first of these is going to be the Mercator map, or also known as the cylindrical map. And remember, in the Mercator or cylindrical map, the areas away from the equator, so those that are away from the equator, are going to become or appear much larger than they actually are. Okay, take a look at this Mercator map here, and you'll notice that Greenland up here appears to be much bigger than it actually is up in here. I'm going to conclude this, as I always do, with a good luck wish for you. Don't forget to write down everything that you've heard on here and everything else you think you might need to know for the test, and good luck.